Hello, my name is Hassan. In this video, I would like to do some experiments to explain and illustrate three important variables related to electrical circuits, namely voltage, current, and resistance. After I explain these variables, I will also talk about the relation between them, which is known as Ohm's law. You can find the list of the materials that I use for this experiment, as well as the link to the Amazon product page. First of all, let me start with voltage. Voltage is the driving force for the current to flow. It is also known as the difference in the electrical potential, which is the potential energy per unit charge. Like massive objects fall from a point where they have a larger gravitational potential energy to a point where they have a smaller potential energy, positively charged particles flow from higher electrical potential to a smaller electrical potential. Conversely, negatively charged particles like electrons move from a smaller electrical potential to a larger electrical potential. For example, this battery has two terminals which are labeled as positive and negative. The potential difference, or in other words, the voltage, is 1.5 volts for this battery, which is also labeled. On the other hand, this battery has a potential difference of 9 volts. If I connect a conducting wire between the two terminals of this battery, from here to here, electrons flow from the negative terminal to the positive terminal, because the negative terminal has smaller electrical potential and the positive terminal has higher electrical potential. This is opposite to the conventionally accepted direction of electricity. Secondly, I would like to talk about the electrical current. It is defined as the amount of charges which passes along a circuit within a unit time. If we use Coulomb as the unit of the charge and seconds as the unit of the time, then the unit of the current will be coulombs per second. And coulombs per second is also known as amperes. So amperes is a unit of the current. If you want to make an analogy, current is similar to the number of cars passing through a specific cross-section on a road in unit time. Third variable that I would like to talk about is resistance. As the name implies, it's a measure of the extent to which a circuit element resists the flow of the charges along it. This can be considered similar to the narrowness of a road, since the narrower a road is, the more difficult it's going to be for the cars to pass. The unit of the resistance is ohms. For example, here I have 4 different resistors. This one is 5 ohms, this one is 10 ohms, this one is 15 ohms, and this one is 20 ohms. On the other hand, there are also adjustable resistances like this, and this is called a potentiometer. By moving this knob, you can change the effective length of the resistor, which in turn will give you a different resistance. Now, before I start the experiment, I would like to talk about the relation between voltage, current, and resistance. According to Ohm's law, if I increase the voltage drop across a resistor, the current will increase proportionally, and this proportionality constant will give you the resistance. Specifically, let us measure the current using an ammeter for different voltages, but for the same resistor. Here I have the setup. Let me explain how I constructed it. Here I have the switch, which is connected to my 1.5 volts battery, and that is connected to one of these resistors. I picked 15 ohm resistance, and that's connected to ammeter, which I'm going to use to measure the current. So if I close the switch, then I'm going to read the current value here. As you can see, the current is 0.1 amperes. It's around 0.1 amperes. Now, This is our first measurement. What are we going to do? Now let's increase the voltage. How am I going to do that? I am going to place another battery, which is going to be in series with this one. For this, I need to take apart this wiring. I need to connect the negative terminal of the second battery to the positive terminal of the first one. Then I have the positive terminal of the second battery and I connect it to the switch. As you can see, now I have 1.5 plus 1.5, which is 3 volts. So I doubled the voltage. Let's see how the current is going to be affected. What I am expecting is it should be 0.2, not 0.1, because I doubled the voltage. Then I should see the current should double too. Let's see. Let me close the switch. As you can see, now it's around 0.2 amperes. I would like to say a couple of things at this point. When I used one battery, the voltage drop was 1.5 volts. And the resistor that I used had a resistance of 15 ohms. And if I divide the two values, I get 0.1, which is the current that I should read in the ammeter. But it was not exactly 0.1. It was very close to that. So there is some deviation. So the deviation can be due to a couple of things. First of all, there can be internal resistances in the batteries that I use. And also, there can be deviations in the values of the resistors that you use because of the changes in the temperatures. Another thing I would like to say is, although it's written 1.5 on my battery, I have never measured it. And I think I should not trust this and measure it. And the way I'm going to measure it is by using a voltmeter. Here's the voltmeter. And I would like to check whether this battery has 1.5 volt potential difference between its terminals. To do that, I need to close the circuit because I need to connect the voltmeter in parallels to the 2 points that I would like to measure. Here I close the circuit and I would like to measure whether I have 1.5 volts between 2 terminals. Okay, let's see. Let's do it this way. Here you can see it's about 1.5 volts. Next thing I would like to say is, in this experiment, I use a resistance which has a constant resistance. Another thing I can do could be to use a potentiometer where I can change the resistance. So let me show you how to use it. I disconnect my resistance and I connect it to potentiometer in this way. One end is going to be connected to the handle of the potentiometer. Like this. And there are 2 points which are at the 2 ends of the potentiometer. What am I going to do is to use only one of these terminals. I pick this one. And I can visually see where the current is going to flow when I turn on the switch. So here you can see the current is going to go along here and then continue from the next wire. That means if I make this length larger, the resistance is going to be larger. Let's see. Let's read it from the ammeter. As you can see, it's not reading anything. But if I turn on the switch, then I start to read something. Okay. As you can see, it's around 0.2. And if I increase this one, you're going to see that the current is going to get smaller, as you see. If I decrease the resistance, the current is going to increase. And I'll make the resistance larger again. The current is going down. I hope you enjoyed this video and thank you very much for watching it. You can subscribe to my channel and hit the notification button if you want to get notifications about my upcoming videos.